There's a great demand for alcohols in industry. We use them to make antifreeze for our engines and for antiseptics to disinfect the skin. If you've ever used a hand sanitizer that works without water, that will have contained an alcohol. We also use the 2-carbon alcohol, ethanol, as an ingredient in alcoholic drinks. The alcoholic drinks industry is huge, and making beer or wine requires science. The process for making alcoholic drinks is called fermentation. The reactant in fermentation is sugar. It comes from natural plant extracts, barley in beer making and grapes in wine making. These sugars have the general molecular formula C6H12O6. Fermentation converts them into ethanol and carbon dioxide. You might notice this equation isn't balanced yet, so have a go as a mini challenge. Pause and continue when ready. Here's the answer. The problem is, this reaction happens far too slowly to be of use to industry, but it can be catalysed by the enzymes of a naturally occurring fungus called yeast. Let's move on to our second route. This one also makes ethanol, this time from a hydrocarbon called ethene. You might have come across it in our videos on hydrocarbon cracking. Here's the ethene molecule and its molecular formula. Here's the ethanol molecule from before. Now look at the numbers of each atom on both sides. Can you think of a very common molecule we can add to ethene to produce ethanol? Again, pause and think, then resume. Well, the answer is the good old water molecule. It's reacted with the ethene in steam form, and the ethene double bond breaks open, allowing addition of H2O. Phosphoric acid is used as a catalyst. Note that ethanol is the only product in this reaction. The ethene route is faster and more efficient as there is no waste product formed, only the useful one. Fermentation also yields carbon dioxide, which isn't useful to us. But ethene is cracked from crude oil, which is a non-renewable resource, so we won't be able to carry on acquiring it this way forever. Plant sugars, on the other hand, are a renewable resource. The ethene route also requires much more energy. The initial crude oil must be heated to a high temperature, and so too does the water to create steam. The fermentation route requires heating only to 37 degrees.